Hello, my name is Cindy Snyder, and I'm the Advanced Clinical Genomics Nurse Practitioner with Georgia Core. I'm happy to be here with you today to talk about hereditary breast cancer. So let's get started. I have some objectives for you today. Basically, I hope that you're going to learn about hereditary breast and ovarian cancer and how to identify who might be at risk for that. And we're going to talk about family history. And we're going to talk about the need for hereditary breast and ovarian cancer screening as recommended by the U.S. Preventative Services Task Force, and give you some information about the screening tool we have available with Georgia Core. So hereditary breast and ovarian cancer is an inherited tendency to develop breast and ovarian cancer at a younger age. But there can be other cancers that you could see in hereditary breast and ovarian cancer, and those include fallopian tube, primary or peritoneal, prostate cancer, pancreatic cancer, and melanoma in the eye. There was some early evidence that there may be an increased risk for colon cancer, but this has not been confirmed with additional research. The majority of cases for hereditary breast and ovarian cancer are caused by a bad copy of a gene of the BRCA1 gene or the BRCA2 gene. But nowadays, instead of just testing for two genes, we actually usually test for many genes. So that's called a panel test. And because there are other genes that we have found that if you inherit a bad copy of a gene, then you could be at increased risk for cancer. So when somebody is identified at high risk based on their family history, it's good for them to see somebody who's trained in genetics that can help them understand what genetic testing means and what those results mean and what they don't mean. So among the general population, about 1 in 400 people have a likelihood of carrying a BRCA gene mutation. Women with breast cancer at any age have about a 1 in 50 chance. If a woman is diagnosed with breast cancer younger than age 40, her risk for having a BRCA mutation is about 1 in 10. Men with breast cancer, and yes, men can get breast cancer, they have about a 1 in 20 chance of having a BRCA mutation. Women with ovarian cancer at any age have a risk of either 1 in 8 to 1 in 10, and people of certain ethnic backgrounds like Ashkenazi Jewish individuals, and they have a 1 in 40 chance. So let's talk about family history for a minute, because family history is actually one of the best, quote, genetic tests we have, and it doesn't cost anything to know your family history. And knowing your family history is a way for you to be proactive about your health and lower your risk for cancer and disease. And it can give you and your healthcare provider a lot of information about what your risk for cancer is and what your risk for other disease is. It's important to know the family history from both sides of the family, not just your mother's side, but also your father's side. We not only share biology with other family members, but we also share potentially the same environments, the same behaviors that can impact our health. So these diagrams that you see here with the circles and the squares, those are actually diagrams that we use to help to create a picture, if you will, of a family history. And in these diagrams, circles are females and squares are males. So based on your family history, you may be appropriate for getting screened for cancer at an earlier age or even having more frequent screenings. So for example, women that have an average risk for breast cancer, they need to start screening with mammograms at age 40. But if a woman has a high risk for breast cancer because of her family history, she may actually need to start screening as early as in her 20s. So with the holidays coming up, it would be a great time then to talk to family members and update the family history. Sometimes family members will want to be private about their cancer diagnosis, and this can make it tough for people to be supportive and to get information. So it may take multiple conversations, but it's important for all family members to be aware of their family health history. Some information you should ask for and why are, first of all, the types of cancer family members had. And you want to try to get the specific type. So for example, many people might be told that they had an aunt with female cancer. Well, what does that really mean? Is it cervical? Is it uterine? Is it ovarian? Or even colon? So there's a whole lot of parts in females below the waist. And getting the specific type is very important if you can. You want to try to find out the age at diagnosis and the age at death. So most cancer in the world is diagnosed after the age of 50. So if you have a lot of family members with cancer at an early age, this could indicate an inherited risk. If family members had more than one type of cancer, that could be a red flag for a hereditary risk. Some tips about talking to your family are: one, try to find the person that knows in the family or the family historian. Usually there's one or two people that seem to know more about the family history than others. And you want to ask about first, second, and third degree relatives. First degree relatives to you are parents, siblings, and children. Second degree relatives are grandparents, aunts, and uncles. Third degree relatives are great grandparents and cousins. So you want to try to talk to as many people in the family as you can, because the more information you get, the clearer the picture becomes. When you're talking to them, explain why you want the information. You're not trying to be nosy. You're just trying to get information so that you and your healthcare provider can come up with the best plan for screening and early detection. And finally, sometimes you can use family memories to help people remember what they may have done with a sick relative. So let's talk about genetics in cancer. Now, human beings have about 20,000 genes in total. So it's important to remember that we get half our genes from our mother and we get half our genes from our father. So remember, you can inherit a bad copy of a gene from either your mother or father. So you heard me say earlier that two genes, the names of two genes, BRCA1 and BRCA2. Well, when you see names of genes, you'll see a lot of letters and numbers. So BRCA1, BRCA2, PALB2, ATM. All of that looks like alphabet soup, and I understand that, but just basically understand this. It's a name. It's the name of the gene. Just like my name is Cindy, the name of one of those genes is BRCA1. It's just a name. So you can think about genes real simple, like a recipe in a cookbook, okay? So the genes are located on the chromosomes. So the chromosome is like the cookbook. The gene is the recipe in the cookbook. They make something. So that's really how to think about genes. When we're talking about hereditary cancer, it's important to remember, again, that you get half your genes from your mother, half your genes from your father. So you can inherit a bad copy of a gene from either parent. Now, all cancer is genetic, but not all cancer is hereditary. So what that means is this: all cancer results from genetic changes in cells, but not all cancer is because one inherits a bad copy of a gene from one of their parents. As best we can tell, only about 5 to 10% of the time is cancer because you inherit a bad copy of a gene. So that means most cancer is not associated with a hereditary problem. It's an acquired problem. Well, how do we acquire cancer? It's not just one thing, because if it were just one thing and one thing only that causes cancer, we would have fixed it a long time ago. So there's multiple factors that impact why we get cancer. It's like a puzzle. It's like a puzzle with a whole lot of pieces. That's why I put this puzzle here. So one of the pieces is our age. As we age, our risk for cancer goes up. Our gender, females have a higher risk for breast cancer than males. Family history. Environmental exposure. Also, our general health and hormonal factors. And our genetics, of course. And then there's other pieces of the puzzle that we still don't even know. So let's talk about red flags for hereditary breast and ovarian cancer. One of those red flags is breast cancer diagnosed before the age of 50. So remember, most cancer in the world is diagnosed after the age of 50. So when you see people in your family being diagnosed with breast, ovarian, colon, uterine, pancreatic, advanced prostate cancer, and those ages are under the age of 50, that's a red flag. Again, ovarian cancer at any age is a risk factor because the lifetime risk for ovarian cancer in the general population of people is less than 2%. So any woman with ovarian cancer, it's appropriate for them to be talking to somebody about hereditary cancer. Multiple cancers in the same person, a woman with breast and ovarian, a man with prostate and colon. But also if you see multiple family members on the same side of the family with the same type of cancer over more than one generation, that's a red flag. So think about it, grandmother, mother, sister, cousin, more than one generation, everybody have breast cancer, that's a pattern. Bilateral or breast cancer in both breasts could be a red flag. Again, Ashkenazi Jewish ancestry. Now the reason for that is what they call a founder effect. And what that really means is that group of people way back were sort of separated from the rest of the world geographically. And you had close relatives marrying close relatives, and that caused these, what they call founder mutations, to develop within these ethnic groups. Having a relative with a known mutation in the family, so if there's somebody you know in the family and they have a BRCA mutation, that's a red flag. A woman diagnosed with triple negative breast cancer, and also male breast cancer. So male breast cancer is actually kind of rare. The American Cancer Society says in 2021, about 2,600 men will be diagnosed with breast cancer. You compare that to females, it's over 200,000 women are diagnosed every year. So male breast cancer is pretty rare. So if that happens in your family, that's a red flag. So let's say you have done your homework and you've realized that, hey, my family history looks suspicious, and you've gone to talk to somebody, a genetic professional, say like myself, or a genetic counselor, and y'all have decided that you're going to do this test. Now, one thing you should know too about doing this test, a lot of people think it's got to be a blood test. Well, actually, it doesn't have to be a blood test. It can be a saliva test. All you got to do is spit into a tube. I know that doesn't sound pretty, but that's what it is. You spit into a tube, and they can extract the DNA from the cells that are in your spit. So it can be saliva. It doesn't have to be blood, okay? But let's talk about what are the possible results we can get with this test. Well, we do get positive results. You can see here in the blue, about 10% of the time we get a positive result, okay? And depending on what gene is the problem, then we talk about how that impacts you and your family. We get a lot of negative results because remember, most cancer is not associated with a hereditary problem. And so we get a lot of negative results. Now, what's important to remember there is a negative result does not mean you will never get cancer. It just means it doesn't look like you have any bad copies of any genes. Therefore, your risk for cancer may be average, and you still need to get screened for cancer when it's the time to get screened. So average risk for women starting at 40 with mammograms. You still need to get cervical cancer screening at the appropriate time. You still need to be aware of your breast. You still need a breast clinical exam once a year, and colon cancer screening if you're at average risk starting at age 45. So we don't want people to think, oh, I'll never get cancer because my genetic test is negative. Please don't. That's not how it goes. The other possible result is an unknown. So we call that a variant, variant of unknown significance. Well, what does that mean? Well, remember I said genes are like a recipe in a cookbook? So what that means is we found a change in the recipe, but we don't know if it messes up the cake or makes it better. And so you can change recipes and make cakes better, but this variant of unknown significance is just that. We don't know what it means. It's a change and we don't know what it means. So that doesn't mean anything's wrong. It just means the lab does not have enough information to determine what it means. At some point, they'll figure it out. And when they do, they send an amended report to whoever ordered the test and to you eventually. And so if you get one of those unknown, don't worry. You just want to keep doing what you need to do in terms of screening for cancer and following up with your healthcare providers. I can tell you more than 90% of the time, those variants of unknown significance get reclassified in the future as not bad. So if you get one of the unknowns, please don't worry too much, okay? So what do you do with the information? What if you get this test done and all of a sudden you found out you've inherited this bad copy of a gene? Well, first of all, this result may help women who are diagnosed with breast cancer understand their options for surgery. So they may choose to have a certain surgical procedure based on that information. There's also treatment decisions, special medications called PARP inhibitors that might be indicated if you carry a BRCA mutation, and you may need additional cancer screening. Also, when it comes to screening, so again, I said women at average risk need to start screening at 40 with mammograms. But if you carry a BRCA2 mutation, then you may need to start screening in your 20s, and you would start with breast MRI. And then at age 30, you would start with adding in mammograms. So that's increased screening. Now, when we're testing, remember I mentioned earlier that we're doing nowadays, we're testing multiple genes or a panel of genes. Because of that, we're actually finding out people that may be at increased risk for other cancers like colon cancer. And so it might indicate the need for colonoscopy screening earlier than age 45. There may be medicines women can take to reduce their risk for getting cancer, okay? So pills, one's called tamoxifen. There may be preventive surgery that people choose to do. So if you're at very high risk for getting breast cancer, you may choose to remove your breast or have preventive surgery to decrease your risk for breast cancer. And that does significantly decrease your risk by over 90%. And if a woman has a high risk for ovarian cancer, she may choose to have her ovaries removed at the appropriate time. The guidelines now state somewhere between 40 and 50, they should have their ovaries removed once they're done having children. But also we need to talk about risk reduction with lifestyle. So if you're high risk for something, you want to try to be as healthy as you can, okay? And that helps to lower your risk as well. So one of those is weight control. Be a healthy weight and avoid weight gain, especially after menopause. Now, I myself, I am constantly, and I mean constantly, trying to get to a healthy weight. I'm just not always successful at it, but I do keep trying. Eating a healthy diet, and that includes 5 or more servings of fruit and vegetables a day. Now, I know that sounds like a lot, but a serving is only a half a cup. So if you eat a half a cup of grapes, that's a serving. If you eat a half a cup of broccoli, that's a serving. So it doesn't take a lot to get to that 5 servings. Alcohol increases the risk for cancers. Breast cancer is one of those. The American Cancer Society says that it's best not to drink. But for people who do drink, you want to drink less than 1 drink a day. And finally, exercise. Really important to exercise. And I know, believe me, I know it's hard to work it into your schedule, but it's worth doing, okay? And it's not as much as you think. The guidelines recommend 150 minutes of moderate intensity exercise a week. That equates to, if you divide it by, 4 days, that's 37 minutes, 4 days a week. That's really not that much. But do you also know that if you do a 10-minute walk 3 times a day, that's equivalent to 30 minutes. So if you can't muster it in your brain to do 37 minutes, do 10, and then just do it a couple more times that day. So remember, 150 minutes of moderate intensity exercise a week. Some of you may be worried about genetic testing and the risk for your health insurance. So let me reassure you that we have laws to protect you against that. The Genetic Information Non-Discrimination Act says you can't use a person's genetic information or how you're made as a pre-existing condition or for terms of employment. So your jobs are protected, health insurance is protected. But the things that don't fall under these laws are life insurance, long-term care, and long-term disability. So if you're concerned about those things, you would want to look into doing something about that before doing the test. These results are part of your medical record, just like everything else, and protected. And the genetic testing laboratory can't use your data without your permission. So understand that that is also you're protected. So one resource that I wanted to, and let me just go back just for a second. I want to kind of come back here because it brought up the thought about the cost. So most insurance companies cover the cost of genetic testing if somebody meets the criteria based on their personal or their family history. And most people pay $100 or less out of pocket for genetic testing. So understand that there are ways to get this done, and there are cash pay options. So you can, let's say you're adopted and you will never have family history to meet the criteria. There are cash pay options where you can get 40 something genes tested for $250, which is a pretty good deal for cash pay. But most people pay $100 or less if they meet the medical guidelines. So I want to talk about a resource that we have for you. It's for the public, and it's called the Breast and Ovarian Cancer Genetics Referral Screening App, and it's located at breastcancergenescreen.org. So this is a screening tool. It's a U.S. Preventative Services Task Force recommended online screening tool that asks questions about family history to assess for hereditary cancer risk and the possible benefit of additional information. The project started in 2012 to provide education to women and promote access to genetics services. And it's funded by a cooperative agreement with the Georgia Department of Public Health. This tool is designed to quickly identify who should be referred for cancer genetic counseling to formally evaluate their family history and discuss the benefits and limitations of genetic testing for hereditary cancer. And it's available in Spanish and English, and anybody in the country, because people do, can go online here at the direct link and go through this and determine whether or not you're at risk for a hereditary cancer problem. When you go to this is the landing page. Once you hit let's start, and again, you can go as a member of the general public. You can either have your data saved or you can do it without having your data saved, whatever you feel comfortable as. If there's a positive result, that means that this person has family history or personal history that meets the criteria for additional evaluation for genetic testing for hereditary cancer. There's also, if somebody happens to go through one of the public health departments, or actually I think, I'm not sure if this is available to the public, but it may be. But if somebody comes through the local health department and they screen positive, they actually have access to education through Myriad Genetic Laboratories, and then I can actually order the test for them. If the result is negative, that means that this person did not have enough family history or personal history to meet the medical criteria for testing. But again, we want people to understand that a negative result does not mean you will never get cancer. You may be at average risk, which most of us are, which means you need to have your cancer screenings and pay attention to your breast. As one patient told me, pay attention to your breast like your hair and your face, okay? So I want to thank you for your time today and for listening. Hopefully you learned something. This is my contact information again. If you have any questions, feel free to give me a call. Have a great day. Thank you.